Hi, welcome to Intro to Python. This is a six-week class. All of the video lectures will be recorded. If you go to classroom.google.com, you will see this Python class. You should have received an invite. If you have not, then you probably need to contact me or contact someone from ICC to get a hold of me so that we can get you added. So if we take a look at what we have going on here, there's four tabs across the top. We've got Stream, Classwork, People, and Grades. So under Stream, we've got a nice little syllabus of what's going to be covered. I'm not going to read each one of these to you, but basically it gives a kind of a basis of what we're going to cover. Some contact information for me, course description, what you basically need. You're going to have some kind of an internet connection. If you need any accommodations, how to contact ICC for those. And then here's the course outline. So we're going to basically be covering chapters 2 through 7. I highly suggest that you read chapter 1 on your own. The first part of chapter 2 is more, I'm just going to cover it very, very lightly when we're going to jump right into the code. This first part here says do all of our editing here. This is an online editor, and I'll show you what we'll need to do to save those that particular item and then to turn it into me, turn it into the grading system. There is a process called Turtle, and I have an editor for that as well. And again, I'm not going to get into Turtle, but if that's something you want to try on your own, by all means, it's kind of a cool little fun program that you can utilize. It actually moves things around on the screen. So classwork. I really don't have a whole lot here yet because I'm just starting the video lectures right now, but I'll have a homework assignment for each week. Right now I've just got 2 in there. Also on this classwork you will see the video lectures. We'll have a section called video lecture, and it will have one for each week, which is basically you'll be listening to me kind of talk and explain how to program in Python. Again, this is an introductory class. We're not going to get into any heavy-duty things, but when you get done with this class, you should have a basic understanding of how Python works. So, the very first thing the Chapter 2 talks about is this thing called the Programmer Development Cycle, and that pretty much is how we basically the birth of a program all the way to how a program is then implemented, and then how it basically the recycling process of how we need to make updates to it. So there on page 31 there's the program development cycle, and again what we have is we have a bunch of boxes, and the very first box we have is let me turn my editor on. And the very first box we have is where we do our design, okay? So we design our program. Now, what that means is it's kind of like when you're going to build a house, you have to basically draw out your blueprints. And you've got an architect who knows the weights of the wall and where you need a bearing wall and how the roof pitch should be and all that. With programming, we have to lay out the logic. We have to basically develop our variables. We have to develop our process and make sure that we don't put the cart before the horse. We have to make sure that we basically make sure that things are lined up properly, that the flow goes from A to B and not in the reverse. And so we kind of sit down, we do those types of things. We're going to cover flow charting here in just a second. Now, back when I was going to school, almost 40 years ago, we had to use, it was a little plastic template and had all these little different shapes inside of it. We had to put on the paper, we had to use a pencil and draw these shapes, and that's how we had to design the logic of our program. Well, now we've got software where we can actually draw those shapes on his computer screen, move them around and that type of thing. My instructor said, make sure you buy one of those big long eraser pens, and I went actually through 2 of those because we had to erase and redraw, erase and redraw. So that's where we do all of that designing. We design all the logic and everything else. Then the next thing that we do is we basically, this is where we actually write the code, okay? So we write the code and we put all of the correct information in there, we build the logic, we do all that type of thing, okay? Now, we don't run it yet, so the very first next thing we have to do is we have to make sure that we correct all of the syntax. Now, what will happen is we have to make sure that things are spelled correctly, that we use the correct upper and lower case. Big difference, upper and lower case in our programs. We have to make sure that we're not using reserved words. So there's a lot of different things that we have to make sure that we're not utilizing improperly. And so that's where we correct all those different errors there as well. The next thing we do is we test the program. Now, in big corporations, we actually have teams that do that for us. I used to maintain, I work at State Farm, so I used to maintain the internet rate quote. And so we would basically, it was actually a web page, very intense, and we would basically make those changes, and then we would give it to a test team. And those folks would test it on all the different operating systems, Mac, Linux, Windows, and then they'd also test it on all the different mobile home operating systems, so Android and iPhone. Back in the day, there was Windows. But anyways, and then they would test all the different types of cell phones. So we could actually do it on a Samsung, an LG, that type of thing. And they really were literally trying to break your code. If you're expecting textual input, they're putting numerics. If they're expecting numeric input, they would put in text. So they're really doing all the things wrong, trying to blow up your code. And testing is very important, because the very last thing you want to do is put code out there for the public to use and there's a bug in it. Now, does that happen? By God, it happens all the time. If you ever notice Windows, when they put out code for their operating system, they'll have updates, they'll have security updates, all these different things because here's how Windows works. Windows, they develop their operating system. And then they have their internal team that test. Then they have volunteers on the outside that are called alpha testers. And they'll say, okay, you folks get the raw code as it stands right now. We think we've got all the bugs worked out. And these folks go through it with a fine-tooth comb, and they find all these bugs. They give it back to the team. They fix them. And it basically kind of keeps circling, the cycles back between those two folks. Once it's gone through the alpha testers, then we go through our beta testers. And these folks they scrutinize everything. Again, they're all volunteers. Back in the day, you could actually sign up to be a beta tester. You basically get the free operating system. Not nowadays, they pretty much give it away for free. But anyways, so those folks would scrutinize, and they'd say, okay, it's bug-free. Is it bug-free? No. So they then say, okay, and they give it to the public. Now the public's using it, and everybody's, they're pushing that code to the very limit, and then they'll basically find an error. They'll give that back to Microsoft. Microsoft will then, and that's why these they have patches. You ever notice the operating system has an automatic update process? What's being updated? Those types of things. Mostly security issues, but also these little tiny things that are found that, hey, we found a bug. They fix it, include it in the update. So that's the testing. So then we come over here, and we've got our correct logic errors, okay? So, again, I've already kind of talked about this. So the testing, we test it to see if there's any things that need to be fixed. And then the fixed logic error is where it basically, again, we fix those errors, and then we ship it out to the public. So what happens is we basically have where it goes from development to write, to fix all of the different, correct the syntax errors. And then we basically go to testing, and then we go ahead and fix all of those logic errors. Then once we're done with that, next time we need to make any changes, we have to basically go all the way back to the beginning and go back to design and start the process over again. Does code ever stay the same? No, I would say code never ever stays the same because there's always some kind of an update needed. Back when I used to work into a particular, we reported to the governments, both state and federal, the different types of wind hail damage, and every year those different government operations was okay. We need to change the report this way. So we always had reports that were always being updated, sometimes on a monthly, sometimes even on a weekly basis. We have to go in and change those reports and get them updated. So they're always constantly changing. So this is what's called the development life cycle. We design, write, correct, test, fix logic, and then it basically comes back around when we had to make new changes. So it's constantly coming into play. You can read about that on page 31, 32. They go into details on all that. On page 35, we talk about the, hold on. We talk about all of the different flow charting. So getting into the design of the process, we basically have this flow charting. So let me kind of clean up this side of the screen a little bit. And flow charting is a way for us to design our logic. And so how that works is, what we'll do is we first have what we call our start. Oh, there we go. So first thing we do, we have our start. So this is our starting point. And then down from that, we have these parallelograms. And those basically are basically represent input and output. So we're probably going to ask the user for some input on the screen. And basically, so our start goes into our input output. And then from there, we just have a rectangle. And that is basically we do our computations. So we take the input, we're going to do something with it, and most likely we're probably going to maybe spit it out on the screen. So now we've got output. So here's another parallelogram. Apologize for the drawing. What's going on here? Hold on. I'll pause the video for a sec. Okay, we'll try this again. So come down here. Let me come up here. I really don't like this. I wish it worked a little better. Okay, so we got a starting, we got input, we do some computation, we spit it out, and then we do a little oval down here, and this is the end of our program. Okay, so that's flow charting. I apologize for the artisticness of this because it really doesn't work well. I wonder, let me try something real quick here. Does this work better? Yeah. There we go. Yeah, so I should have probably used that. Anyways, so you kind of get the flow. You kind of see that on page 35, and so that's flow charting. So that's basically where we would do our design. Okay, so that's my little demonstration of how we do the design development life cycle and how we do flow charting. Now let's talk about inputs and outputs. So Now, I do want to say this is I do have all of the different source code. If you click on classwork over here, there is source code. You can click on that. It's a complete zip file. Um, you can basically download that, unzip it, and all of the code that we're going to basically be using is there, and you can open those up and kind of follow along. So here's probably the best way to do it. Is I'm going to go ahead and open up this editing. So we click that, and this is the Python editor. Okay, it's got some default code in there, and don't worry, we're not going to cover this yet. We're not quite there. We're a few chapters away from this. So what I'm going to do is I'm going to open up come on, computer. So I'm going to open up the source code. And this is how this, again, I'm going to show you this one time. This is what you'll need to do as we're kind of going through this. So So the very first program there on page 37 is called output.py. So I go to output.py, I'm going to open it, and I'm going to open it in Notepad. And what I'm going to do is I'm just going to do this. I'm going to do a Control A to get it all, and then Control C to copy it. And I'm going to come over here to the editor. I'm going to click up here in the editor. I'm going to do Control A and Control V to paste it in. So now we have it. So this is just simple how to use output in Python. We use a print statement. We do print, and inside the parentheses, I have quote, K. Austin, 123 Full Circle Drive, and then Asheville, North Carolina. When I want to run the code, I just click run, and boom, right down there it shows K. Austin, 123 Full Circle Drive, and you'll notice it says process exited, return code 0. We always want to try to get a return code 0 that says everything ran fine. You hit the enter key to basically exit out. That's it. So that's as simple as it gets. Okay. Now, as you're writing your own code, what you want to do for me is you can basically copy that code, do a Control A, a Control C to copy it, and again, I would open up Notepad, and I would do a Control V to paste it in, and then you can do a File, Save As, and this time I'm going to change the save type to All Files, and you can call this, I don't know, homework01.py, and then save it. I'm going to put mine in my download folder, and I'm going to click on save. And then when you go to your, in this case, my download folder, here's my download. I go here, I notice there is my homework01.py, and that's what you'll be turning in for your homework assignment. Okay. We can use Eclipse. I don't know if any of you are familiar with Eclipse. It's an editor. We utilize that for Java. We can set up Eclipse for Python, but it really takes a lot. We probably have to spend an entire class just trying to get, probably at least half a class, just trying to get that set up. Where if we just use this online editor, it's just so much easier. So anyways, so that's how you'll basically do that. Okay, so simple output. Now let's do this. Let's open up, well, output 2, basically, the only difference between output 1 and output 2 is it puts in double quotes for each one of these. And it's going to work just fine. So if I click run, we get the same exact output. So basically what you're trying to show is we can use single quotes and double quotes. Now, I'm going to open up apostrophe. And apostrophe, let me bring this over here. The whole point of this code is you'll notice I've got double quotes. Inside of there I have a single quote. So if you do need to use a single quote for something like "Don't fear, I'm here," notice the apostrophes. When I run this, the apostrophes will show up just fine because they're enclosed within double quotes. So that's the whole point of that little exercise there. We can also do this, which is display quote. So if I open up display quote, you'll notice it's surrounded by single quote. It says your assignment is to read Hamlet by tomorrow. Notice it's got double quotes inside that, but it's enclosed by single quotes. So it's kind of reverse of what we just saw. And that is a nice way to basically show double quotes in your output. Okay. On page 39, we got a nice comment, and comments. I'm going to put up comment 1. And how we start a comment is we just put a pound sign in. So here's what happens. The pound sign basically sees that. Now let's back up for a second and let's talk about how Python works. So when we have languages like VB, .NET, and we have Java, we have C#, some of these other languages, they actually have a compiler. And what it does is it takes this textual code and it compiles it into what's called machine language. And then that machine language is then basically what is ran, and we can have two separate files. For example, Java has a .java, which is textual. We can read it. And then we have a .class, and that is basically compiled into machine language. If I opened up a .class file, I couldn't read it. I have to be a computer to understand what's going on. Python's a little different. Python is what's called an interpreter. When we run this, it takes that code and compiles it and runs it as is right now. On page 18 in chapter 1, it talks about the difference between compilers and interpreters. It says a compiler is a program that translates high-level language into some separate machine language. The machine language program can be executed at the time when it's needed. Python language uses an interpreter, which is a program that both translates and executes the instructions in a high-level language program. So it basically takes what we do, it compiles it, and runs it at the same time. Now, here's kind of the good and bad of the both. Python is kind of designed as what we call rapid application development. It's a great way to just make a program very, very quickly and run it, execute it, and it's ready to go. The problem with it is if you give someone some Python code, they can actually see your code. They can actually go in and modify it. With Java, on the other hand, I write a program. I then have a class file that I give people to run. They can't see my code. So I can actually sell the program. I can actually develop software in Java, and nobody has access to my code. So when I make updates to my code, I then basically make an update and send out a new class file of people who have purchased my code. Where Python, like I said, since it's an interpretive language, you basically see the code as is. So that's kind of the good and the bad about both. Okay. So just realize that Python is an interpretive language, and a lot of the other languages are compiler languages. Okay, so let me get back to where we were. So we talked about comments. We have a hashtag. Now, those comments can go, I'm going to open up comment 2. And I'm going to do a copy, and then let me come over here and select all and do a select all and paste. And you notice we got that the pound signs after. Okay, so whenever the interpreter, the compiler, sees a pound sign, it says, I'm going to ignore everything to the right of the pound sign. So we can put those pound signs anywhere, but realize if I want to comment this line out right here, I can put a pound sign right there, and that basically then comments out the entire line. Because remember, everything to the right of the pound sign is comment. So basically the compiler completely ignores it. Now, what are comments used for? Well, comments, think about this. I write a program. I'm not going to be the one who maintains that program forever and ever and ever and ever. So I might write the program, I put it out there in production, and then there's another team that has to come in and modify it as needed. So what we do is we put comments on our code to always help that person who's coming up behind us, tell them what we're doing in certain places. Hey, this is what this means. This is what we're doing here. This computation is trying to basically do this. And so basically we're trying to give instructions for someone who has to maintain this code behind. Because I'm going to say that I tell the story in every single one of my programming classes. When I was basically going to college, we were taking a COBOL class. And in every class, it seems like there's that one guy who basically really has a good brain, and they basically get it. And our guy was Bill. We always went to Bill for all the different help. Well, we worked on this monster program, and I had over 900 lines of code. And I asked Bill, I said, Bill, how many lines of code did you have? And he said, he only had 300 and some. I went, 300 some, 1/3? I says, it works? He goes, it works great. I says, hey, once we get our programs graded back, I want to see your code. So that happened. I was looking at Bill's code. I tell you what, it was so slick and so, I guess, using the latest and greatest and the shortcuts and all that kind of stuff. It was, I couldn't read it. I had to literally read each line and try to figure out what it was doing. So the whole point I tell that story is, now I wasn't a great programmer back then. I was by no means, but my code was readable, and that really says a lot for programs. Is if I have to spend 3 days trying to figure out what a program's doing to maintain it, that's not good. Now, if I get a program and I can read through it and it's got a lot of good comments and it takes me just a few minutes or maybe an hour or so just to kind of figure out what's going on, that's a good program. So whether it uses less memory and uses less computer cycles, that type of thing, a good program really is one that's easily maintainable. Okay, so that's basically what comments do for us. Okay. So let's talk about creating variables. So what we've seen so far are print statements. They just print text. And we got double quotes and single quotes. And we've got comments. And again, put lots of comments in your code as we're basically using. So let's look at variable demo. I'm over on page 42. So variable demo. So let me do a Control A, Control C. Come over here to Control A, Control V. And so this program demonstrates a variable. I just got room equals 503. Okay? So I've just created a variable. The name of the variable is called room, and it basically contains the number 503. And then it says print I'm staying in room number, and then I say print room. So when we run this, I'm staying in room number 503, because room is a variable that holds the numeric value 503. Simple enough. Now let's take a look at variable demo 2. And here I've got top speed 160, distance 300. Okay, so it says create two variables, top speed and distance. And then we got a comment that says display the values referenced by the variables. The top speed is top speed, the distance traveled is distance. Simple enough, we run that. The top speed is 160, the distance traveled is 300. Okay. On page 43, it talks about, there's a warning there, a big box, talks about making sure you cannot use a variable until you have basically created it. So if I basically did this, if I put these two variables down here and I tried to run this program, I would basically get an error. I click run and it says, hey, I don't know what top speed is. I don't know what distance is. And the reason is they have not been declared yet. We have to declare the variable before we can use it. So again, those are called those syntax errors that we have to fix on our development life cycle. Also, on page 43 is a note, and it says Python variables work differently than variables in most other programming languages. A variable memory location holds that value. When you assign a value to a variable, the value is stored in the variable's memory location. In Python, however, that's most languages. However, a variable in memory location that holds the address of another memory location. When you assign a variable or value to a Python variable, that value is stored in a location that is separate from the variable. Okay, so it basically says the variable's here, the value is here, two different places in memory. The variable will hold that address. So basically what it says is, so the variable's sitting here. So for example, top speed, the variable's sitting here. What's inside that variable? The address of where the data is actually stored. So in this case, top speed has 160 over here, and inside of top speed is the address to where that 160 resides. So it's a little different than what we see in other languages. And so that is why Python, instead of saying that a variable holds a value, instead of saying it holds a value, it basically says references a variable. So it basically says, hey, I'm telling you where the address of where the actual data is stored. On page 17, we have a list of Python keywords, and those are keywords we cannot use for variable names. They actually are reserved words that Python uses for different things. So we cannot use those as variables, or we can't use them as module or methods. We can't use them as class names, that type of thing. So just realize that. So page 17, stay away from those words. We should be okay. Variable names cannot contain spaces. If it contains a space, if I were to get rid of this and call it top speed, that basically says I'm looking for a variable called top and I'm looking for a variable called speed. Okay, so just realize that. So it cannot contain spaces. The first character must be a letter or an underscore. It can be an underscore, but it's got to be a letter or underscore. It cannot be a numeric value. After the first character, it can be anything from A through Z and any numeric value and an underscore. Uppercase and lowercase letters are okay, except what we like to do here is a lot of times, like say top speed here. Top speed, we would like to keep it separated by an underscore. Or we can use what is called camel casting, where I would basically have top speed, the S in speed would be uppercase. Now when we read it, so because if I made that lowercase, that looks like one word, and it's really, it's not that hard to read, but it's kind of hard. It's hard to see two separate words there. But if I make that an uppercase S, that's called camel casting because it's lowercase and then uppercase comes back down. That's got a hump, so it's called camel casting. And so now we have top speed. Now that's easier to read. So I have to come down here and do the same thing. So top speed. So totally works, totally doable. It really all depends on how, now this is up to you. How do you want to make your variables? If you have two separate words, do you want to separate them by an underscore? Dashes, you cannot use a dash. A dash is a minus sign. If I were to do top dash speed, that thinks that there is a variable called top, a variable called speed, and it's going to try to subtract speed from top. Not doable. Underscores, letters, and numbers are all we can use. No other special characters are allowed. Top of page 45 it shows some legal and illegal processes. So I've got units per day separated by underscores. I've got day of week using camel casting. I've got 3D graphs, starts with the number 3. It's going to error out on us. We can't have variables that start with numbers. June 1997, totally legal. Mixture, #3. Remember, pound signs are comments. Slashes do different things as well. Dashes, like I said, are minus signs. So again, letters, numbers, underscore. First character has to be a letter or an underscore. Okay. Now, variable demo number 3. So it takes what we've learned so far, and now we've got room equals 503, and now I could say print, I'm staying in room, comma, number. Let's see what happens. I'm staying in room number 503. Now it has it on one line. Now what you'll notice with Python is you'll notice that it automatically puts a space. Whenever we use the comma separator in a print statement, it will automatically put a space in between them for you. So we don't have to space it out. So I wouldn't have to do something like this and basically kind of take care of the spacing myself. What's going to happen is it's going to add an extra space in there. Now I have 2 spaces in between 5 and 503, or number and 503. So we don't have to do that. Python will take care of that for us. So just know that as well. Bottom page 45 talks about variable reassignment. Variables are called variables because they can reference different values while the program is running. Let's take a look at variable demo number 4. So here I've got dollars equal 2.75, and print, I have dollars in my account. So I have comma, dollars, comma, in my account. And then I come down here and say dollars is equal to 99.95, and I print, but now I have comma, dollars, comma, in my account. So what we've just done is we start out with dollars holding 275, and now it holds 99.95. Now remember, with Python, the variable holds the address of where that number resides. So 275 might be sitting here, and 99.95 is sitting over here, and all we're doing is changing the addressing of where those numeric values reside. So again, we run it. I have 275 in my account, but now I have 99.95 in my account. Again, because we use the commas within our print statement, it automatically puts the spacing in for us. Okay. One thing, like I said, we can't do this. I can't say $275. If I tried to do that, it would basically blow up and say, sorry, I don't know what a $sign is. That's a special character that I can't use. If we want to do that, we would have to do this. I would do have space $, and now I have down here space $, and now when I run it, watch what happens though. It's got I have $, space, because remember, Python puts a space in there. We're going to learn later on, not in this chapter, but another chapter, how we can get rid of that spacing. So, but we'll cover that pretty extensively. Okay. It says, because different types of numbers are stored and manipulated in different ways, Python data types are categorized, and basically they're categorized in different categories in memory. When an integer is stored in memory, it is classified as an int, I-N-T. Again, don't worry about this right now. We're going to get more heavy into that later on. And when they call it a real number, which is basically a decimal number, it's going to basically be classified in memory as a float. So we basically have two distinct types. Now, in any of you Java developers or VB or some of the other languages, we actually get more detailed. We have shorts, ints, and longs, which are all integer numbers, and we have floats and doubles, which are decimal numbers. And in Python, we're just going to worry about ints and floats. Ints and floats, that's all we're worried about. Now let's talk about textual data. Okay, so let's look at, and in VB, oh, sorry, VB, I got VB on the brain. In Python, we don't call it text, we call it a string. I think most languages actually use a string data type. Whenever you say string, we're actually talking about text. So I'm going to look at string variable. And there I have, wow, that's not what it looks like in the book. Okay, so let me do this. So I'm going to pause for a second. Okay, I fixed that. So this is basically what it says is we're going to create a variable in reference to strings. And first of all, we're going to create first underscore name, and it's set to single quote Catherine, and last underscore name is equal to single quote Marino. And then we got a comment that says display the values referenced by the variables. We print first name, comma, last name. Remember, it'll put that space in there for us automatically. We click run, and there is Catherine Marino. So, two data types for numerics, int, float. And then we have a third one for textual data only called strings. Now, can strings contain numeric data? They certainly can. But they are strings then. They're a text. You can't do computations on a textual numeric value. So we'll cover that a little more extensively. Now, can we do this? Can I say, they basically say we've got x equals 99. I'm going to say print x. And then I come down here and say x is equal to take me to your leader. I'm going to say print x. Is that going to work? Well, let's take a look. And there it is, 99, take me to your leader. And this is after a variable has been assigned a type of int, it can be reassigned. It can actually be reassigned with a different data type. And that's perfectly legal in Python. Can't do that in Java. So there's some good benefits to Python. Now, do you want to call that good? Do you want to call that bad? Well, it all depends on how you look at it. Good in the sense that, yeah, variables are truly a variable, but kind of bad in the sense that I can throw anything in there and basically it's going to be just fine. But we'll see how we can control that a little bit more later on. Now, how do we get input from the user? Well, let's open up string input. And here I've got first name equals input, left paren, enter your first name, space. Now notice we got a space there, and that's very important. And then I've got last name equals input, enter your last name, colon, space. And then I'm going to say print hello, first name, comma, last name. So let's go ahead and run this. And then what happens is, on the screen down here, it's going to say, Okay, I'm going to refresh the screen. And we'll try it again. I swear to God, this worked when I did this the other day. And I don't know why it's not working now. This is crazy. It should pop up down here, enter your first name, colon, and we just type right down here in this box. So I do not know what is going on here. I'm going to pause. Okay, I went ahead and opened it up in Chrome, and it seems to work there. Okay, so I'm going to go ahead and click Run. Notice when I hover over that, there it is. It does, when I hover over there, it says you can hit F8 to run it. So type in your first name, hit the Enter key. Now type in my last, hit the Enter key, and there it is, hello, Mark Webb. So we can actually get input from the user from the screen, so we don't have to rely on typing the text on there. Now, one thing I did notice, and I've been using this for a couple, 2 or 3 weeks now, going through the different training. I didn't realize there is a save up here. If I click Save to a disk, this allows us to save this, and we can actually type in a name, .py. Python always has a .py extension. And what happens when I click Yes? Okay, where did it save it? I do not know. Oh, it probably saved it, so it's saving still. Okay, now it's done. I'm going to go to my folder and put it in downloads. So it defaults to downloads. Okay, so you don't have to copy and paste it into Notepad and then save it. You could do that if you wanted to, but you can click Save right here and basically that. And it looks like we can also click on this folder and actually open up. So I could actually we can actually do that, okay? So when you open up the source files, you can actually open it up here as well. So here I could do string input.py and open it that way. Okay. And what happens when I click Save? Is it going to save it in the same spot? Let's see. No, it still went to downloads, so it defaults to downloads. Okay. So over on page 51, we could do something like this where I can say, so let's say I said hours, now I'm going to use X. X equals input, enter hours worked, colon space, and then down here I'm going to say hours is equal to INT X. So what I just did right there is I got input from the user, and when I use the input screen, I believe it defaults to string. So right here, I'm going to say hours int. So basically, I'm telling it I want the compiler, the interpreter, I should say, I want the interpreter to take that x and convert it into an integer data type and put it into the variable hours. So now what's sitting in hours right now is an integer data type. Or I could say HRS is equal to float, I'm stuck in Java, float x, and that will convert it to a decimal number, a decimal place number, and that will basically be put into hours. So HOURS is an integer data type, HRS is a float data type. Okay? So just realize we have that. Now, we could do this as well. We could actually do it a lot simpler by just saying int left parenthesis right parenthesis. I could just say int input, and what that will do is whatever input we get will be converted to an int and put into x. So we can be very, very specific on how we want to read that input. Okay. So let's take a look at input on page 52. I'm going to keep my... All right, cool. So here's input. So it's got name, input, what is your name, age, int, input, what is your age. So whatever they type in there, it's going to be converted into age, an integer, and put into age. And then income float, what is your income? So it's going to take that, convert it to a float, and put it into income. Then I can say, here's the data you entered, name, age, income, income. Run it. What is your name? What is your age? And what is your income? I click on it, and there it is. Here's the data you entered. Name Mark Webb, age 62, income 50,000. So we can tell it when you create that variable, I want you to basically store it in this data type. Okay, so now once we've got some numeric values, what are we going to do with it? Well, we can actually do some calculations. Over on top of page 54, those are the different math operators we can use. We can use a plus sign, a dash for subtraction, an asterisk for multiplication. We use an asterisk. We use a forward slash. That is for division. 2 forward slashes is specific for integer division. We'll talk about that more extensively. Now we have a percent sign for the remainder. What that means is if I take, let's say I take 5 and divide by 2, and I basically, instead of doing a forward slash, I do a percent, that is going to only give me the remainder. So 2 goes into 5 twice with a remainder of 1. So what we're going to get back is 1. So if I do 5% 2, I'm going to get back a 1. Now, that is a great way to see if a number is numeric. I can say if x percent 2 is equal to 0, I know it is a numeric, or a positive, an even number as opposed to being an odd number. So let's take a look at simple math. And there I have salary as $2,500. I've got bonus. Now, notice I didn't put a data type in front of it. Python is smart enough to know, oh, I see a 0.0. I'm going to go ahead and default to a double data type. Down here I see a 0.0. I'm going to default to a double data type. So I've got salary 2,500, bonus 1,200. I'm going to say pay equals salary plus bonus. And I go ahead and print your pay is pay. So whatever 20, so what is that, 3,700? I click run. And there it is. Your pay is 3,700. I noticed that it defaulted to a 0.0 data decimal point because basically defaulted to a double. Okay, so throughout the book, we have these things called In the Spotlight, and they really get into a whole lot of detailed stuff. And this one is called Calculated Percentage. It says you're writing a program that works a percentage. You have to make, so it basically says this. We're going to get the original price of the item. We're going to calculate 20% of the original price, and that's the amount to be discounted. And then we're going to subtract that discount from the original price, and we're going to say this is the sale price, and we're going to display that sale price. So let's open up sale underscore price. So we got our comments in here, and we got original price is equal to float inputs. We're saying whatever you input off the screen, we're going to convert to a float, put it into original price. We're going to ask the user, hey, enter the original price of that item. We're going to say discount is equal to original price times 0.02. So there's the 20%. So now discount is what we're going to take off of the original price. We're going to say sell price is equal to original price minus the discount. We go ahead and then print the sell price is sell price. So when we run this, the original price is 100. Hit the enter key, and it says the sell price is 80. So 100 times 0.2 is 20. We subtract 20 from 100, we get 80. Simple, simple enough. One more thing I didn't talk about after the remainder, we got the percent. We also have two asterisks. That's exponentiation. So if I wanted to raise 2 to the 4th power, I would do 2 asterisk asterisk 4, and that raises 2 to the 4th power. I'm sure you guys all know the order of operations. They call it the operator precedence. I'm not going to go into that. Just realize we do all exponents and things in parentheses first. Then we do multiplication or division, whichever comes first. Then we go back and do any subtraction or addition, again, whatever comes first. So I'm not going to spend a whole lot of time on that because that's something you probably should have learned in grade school, even high school. So grouping with parentheses, we basically, again, we can do that as well. So let's take a look at test score average. And we're going to talk about, we're going to show examples of parentheses. So here we're got 3 test numbers, test 1, test 2, test 3. We're going to basically say enter the first score, enter the second score, enter the third score, and notice we're converting them all to floats. And we're going to say average equals test 1 plus test 2 plus test 3, all divided by 3.0. And so, which is how you get the average of something. There's 4 items, you basically add them together and divide by 4. In this case, we got 3, we divide by 3. And we're going to print the average score is average. So notice we're using parentheses. So it's going to do whatever's inside the parentheses first, and then it's going to do the division. So I do run. We'll do 100. We'll do 75. And then we'll do 50. And the average is going to be 75, obviously. Exponents. Again, if I wanted to say x equals 2 and y equals 4, then I can say print x asterisk asterisk 4, which is y, and that's going to basically print 2 to the 4th power. Again, run that. And there is 16. So 2 times 2 times 2 times 2 times 2. Okay, so let's take a look at time converter, and this is kind of a cool. Now, one thing I do want to notice how it keeps track of all the different ones we've had. So it keeps all those open. It just keeps adding new tabs at the top. So I'm going to open up time converter. Now let's take a look at this guy. We got total seconds is equal to float. So whatever we're going to get from the input from the user, we're going to convert to a float, put into total seconds. Now we're going to say total hours is equal to total seconds divided by, notice it's 2 slashes. That's an integer division, okay? So we're basically saying we're dividing by dividing by 2 integers, okay? One integer divided by another integer. I've got minutes, because if I use another slash, it would convert to a float. So now I've got hours, okay? Now, why did I do integers? Well, because I don't want any decimal places. So I just want to get that whole number of hours. So, because we know that 3,600 seconds is basically 1 hour. So when I divide the total number of seconds by 3,600, that's going to give me a whole number of hours. Now, I'm going to take minutes is equal to total seconds, again, divided by 60. So we're doing an integer division, no decimal places. And once it does that, we're going to basically do a percent 60. Now what that says is, whatever number you get, divide it by 60 and only display the remainder. So what that's going to give us now is a total minutes, okay? Then, because we already got hours now, then we get minutes. Now if I say seconds equal to total seconds percent 60, that says take that entire large number, divide it by 60 and give me the remainder, and that will basically give us how many seconds are left over. Because once we strip off the hours and the minutes, we just want to show the seconds that are left over. And then it's going to say here the time in hours, minutes, and seconds. Hours, hours, minutes, minutes, seconds, seconds. So let's run this. And let's go ahead and type in on the book, it's 11730. Hit the enter key, and it says that is 3 hours, 15 minutes, and 30 seconds. So pretty cool. Now, notice it printed it in float. The reason it printed it in float is because it started out in float up here, and when we did the decision, ours ends up being a float because of the total seconds is also a float. But when we do a integer division, all that basically does is strip off any decimal places. That's all that it does. It still keeps it as a float, but it just strips off any decimal places. So the difference between a slash and a double slash is an integer, strips off all decimal places. It doesn't round. I want to make that very clear as well. It does not round. It just truncates. Okay. Page 61 talks about converting math formulas to programming statements. So in there it's got x equals a plus b over c. So we have to realize that that is a plus b in parentheses divided by c. So just realize some of the things we have to do to convert algebraic equations into strings that we have to then put into Python. So we got another in the spotlight, and it's basically about converting a math formula to a programming statement. So we got P equals F over 1 plus R, and outside of that in parentheses it's raised to an N power. So it basically says P is the present value. F is the future value, R is the annual interest rate, and N is the number of years you plan to have that money accumulate. So what we have to do is we have to convert that into a formula. So let's take a look at future value. So here, we're going to basically say future value is equal to float input. So we're going to basically take whatever the user gives us, convert it to a float. We say, what is your desired future value? And then we're going to say, okay, what is the annual interest rate? And then we're going to say, okay, what years, so how many years do you want that money to grow? Okay, so you got your future value, you've got your interest rate, you got how many years you're going to let it sit there, and it's going to tell you what you need to basically deposit in order to get that future value. Okay, so that P equals F over 1 plus R in parentheses to the nth power looks like this. So present value is equal to future value divided by 1.0 plus rate raised to number of years. So exponent is asterisk asterisk. And then we'll basically say, okay, you will need to deposit this amount. So let's run it. And our future value is $10,000. So 10, 1, 2, 3. I hit the enter key and it says the annual interest rate. And we have to type it in since it's percent, we have to use decimal places. So I want this to be 5%. So 0.05. How many years are we going to let it grow? We're going to let it grow 10 years. And it says, okay, if you want $10,000 in 10 years at 5% interest, and you're going to leave it there for 10 years, you're going to have to deposit $6,139.13. So you deposit that, leave it set for 10 years at 5% interest, you will have 10 grand at the end. So and they utilize this type of an equation all the time, and all the different banking and financial advisors of types of folks. Okay. Let's talk about string concatenation. That's taking textual information and gluing it together. So concatenation is gluing things together. So let's open up the concatenation program. And so here we have first name, enter your first name, last name, enter your last name. We've seen this before. And then I'm going to say full name is equal to first name concatenate. Notice we've got a plus sign. Well, that's kind of weird. Plus signs are usually for addition. Well, they also can be used for concatenation. So here I've got concatenate. Notice I got single pick, space, single pick. That's important because when we use the comma, remember how we said print this, comma this? Python would put a space in there. When we do concatenation, it's as is. It does not put, because notice that first name, what do we type in? There's no space at the end or beginning. So we have to utilize the space in order to make sure there's a space between first and last name. If we did not do this, it would have both of them butted up together end to end. Now notice down here when I say print your full name is, we didn't use the comma this time, so notice I got a space after is, so we have to basically make sure we utilize a space in these cases so that we can have proper spacing. So let's run it. I type in my first, I type in my last, and there it is. Now notice what I did there. I did type in an extra space after the K. I shouldn't have done that because notice I put 2 spaces there. Let me run it again and try it better. So M-A-R-K, B, and there it is. Your full name is, I notice there's a space after is, and there's a space in between Mark and Webb because of this space right here. So concatenation, it's ways to glue strings together. Now we have to be careful. If, for example, if we wanted to do this, I wanted to do print what are they doing here? Yeah, I'm going to print one, do single quote, 1, 2, 3. So when I run that, it puts 1, 2, 3. But let's do this. I'm going to do a concatenation symbol here instead. Now when I run it, watch what happens. That's basically all glued together. So what we can do is we can actually have what's called a separator. Is if I did go back to the commas, I could at the end down here do space or a comma SEP for separator equals single quote space single quote. Oh, I'm sorry. Okay. Now notice it's 2 single quotes butted up against each other. Now watch what happens when I run this. It says, hey, you're going to separate them by nothing. So Mary talked about earlier how we can control how they're separated. So now they're separated. Now if I change that to a space, watch what happens. Now it separates by a space. I'm going to change that space to a dash. When I change it to a dash, now look at how it's separated. 1 dash 2 dash 3. So we can use SEP equals, and that's a separator. It says, how do you want these to print when they're separated? Or how do you want to separate these items? And we can actually use SEP equals and tell it what the separation character is going to be. Now, another thing we can utilize on page 69 is what's called escape characters. Now, escape characters allow us to, for example, what if I wanted to use a slash in my word? Or I wanted to have a tab, or I wanted to have a new line. I wanted to cause it to go to a new line. Or if I wanted to hard code, instead of using a double quote and a single quote inside there, or a double quote, I can actually use a double quote around things and actually put a double quote inside there. We can use that via a escape character. So for example, I could do this. If I did slash n here, I'm going to get rid of the separator. I'm going to do a slash n2 and a slash n3. Now watch what happens when I run this. 1, 2, 3 on separate lines. The slash n says go to a new line. Okay. Now what if I put 2 slashes in here and 2 slashes in here? And I run it. Now it's got a slash in front of the 2. So when I got 2 slashes together within quotes, again, this is text, this is string, that says, hey, I want to print a slash here. Because if I just do a slash by itself, it's probably going to work. Yeah, it still works just fine because it's inside of a quote. But if I put 2 slashes, that's always going to ensure that we're going to get 1 slash, okay, textually via a string. Let's say I wanted a tab. I can actually do a T, a slash T. It's a lowercase t, by the way. Lowercase t, watch what happens. It's 1, tab 2, tab 3. Puts a tab in there. What if I wanted to have double quotes around the 1? So I could do a slash double quote, and then at the end of the 1, I do a slash double quote. Now when I run this, it just put double quotes around the 1. Okay, so escape characters is kind of a nice way to us to control certain things like tab and new line and quotes and slashes and that type of thing. Single quotes as well. Okay, over on page 70, we got this thing called f-strings, and f-strings is a way for us to, it's kind of like concatenation, but it allows us to do a couple things. One, allows us to insert a string, a piece into a string, let's say for print. We can also format it. So, so let's do this. Let's just do, I've got name equals Mark. And then I can come down here and say print it's a lowercase f, and then single quote hello, and then ending single quote. Well, I can actually do hello space, and I'm going to put a, now in order to use the variable, I have to put in a brace in there. Whoop, not a square, a squiggly line brace. And I'm going to put in name, and I'm going to put in a period, and then an ending single quote. So let's take a look at this. So I've got my variable name, Mark, and then inside of here, I'm going to say print, and the F tells us this is a print, this is an F string. I'm going to print the word hello, and then the brace tells me, hey, what's inside of here is the variable. So print this variable. Now notice I've got a space after the O and hello, so it's going to have space and then name. And when I click run, there is hello Mark. Okay, so that's as simple as it gets for an F string. But we can also do something like this. I could actually say, X equals 10, Y equals 2, and then I can say print, left parenthesis F, I can say single quote, the value is space, left brace, X plus Y, right brace, and ending single quote. Okay? And now I've got the value is, now the F says this is a print, this is an F string. So again, when I run it, hello Mark, the value is 12. Okay? It's kind of a nice way to do that. Now, not only do F strings allow us to include some type of a variable inside of a string, but we can also do formatting. So let's first look at F string no format. So here is F string no format. And we got amount due is 5,000.0, that makes it a float. I got monthly payment equal amount due divided by 12.0. Print F, the monthly payment is, left and right brace, monthly payment. Okay, so simple enough. The amount due is $416.6666666. Okay, the dot 66666 doesn't look right. So how do we fix that? Let's take a look at F string rounding. And now I've got amount due is 5,000. Monthly payment is amount due /12. Now watch this. I've got F, this tells it's an F string. The monthly payment is left brace, monthly payment. Now I've got colon dot 2 F. Now, this F is completely different from the F over here. This first F is saying this is an F string. This F says this is a float. And I want you to round to 2 decimal places. So the colon is a separator. The colon says print monthly payment. And the colon says after the colon, I want you to round that number, monthly payment, to 2 decimal places in a float value. So now when we run it, I've got $416.67. So that's a little more readable. Now, what if we have a big long number and we want a comma for 1,000 separator? So let's go ahead and look at dollar display. Now, I'm back up here a little second. Every time I'm saying let's open up, you can pause this video, pause it at any time, and you can then open up the same thing that I'm doing, and then you can click run. I may be going a little too fast, but anytime you can by all means, please pause this video. You can also pause the video and maybe go back to the back of the chapter and work on some, I would start with the number one. Number ones are pretty easy. For example, if you go to page 114, there's a programming exercises. I would highly suggest as you kind of do, as you're watching this video, pause the video, go back and try doing number one, try doing number two, try doing number three as you go along, and that will kind of help build your skills up. And then at the end of the chapter, again, I do have homework assignments that you need to work on as well. Okay, so let's do this. Let's open up dollar display. And so here I've got monthly pay is 5,000, annual pay is monthly pay times 12. And then it says your annual payment is $sign. Now notice the $sign is butted up against the brace. There's not going to be a space. We have to put the spaces in where we want them. Annual pay colon. And after that I've got comma 0.2. The comma says if this has a thousandths, use the comma thousand separator. The 0.2 says round this to the nearest 2 decimal places in a float format. And we got the ending brace as well. So let's run it. And we're going to type in, it did it for us. So your annual pay is $60, 000.00. Okay, pretty cool. So the F string allows us to put in, kind of build our variable right into the string. And again, we have to put the spacing in. This is a nice way for us to put the spacing in, kind of like concatenation did. We can also do percentages. So let's say I wanted, so if we go back to our, here's our rounding. Let's do this. I'm going to say int rate is equal to 0.05. Okay, and then I'm going to say print f single point interest rate is, and we do a space. We got to make sure we put a space in here. And then I'm going to do brace int rate colon percent. Ooh, what is that going to do? And I put my ending pick mark. Okay. So let's take a look at that. So now that says I've got interest rate is int rate. Let's run it and just see what our outcome is going to be. Wow, look at that. The interest rate is 5.0000. So let's do this. Let's do 0.2%. And let's click run. And there it is, 5.00. Let's do 0.1. Let's do a 0.1. And we run it, and there is, interest rate is 5.0%. So we use a percent, that's going to convert that numeric value into a percent value. Okay. Now, another thing we can do is we can say, hey, I want this value to take up this many characters. So on page 75, we can specify a minimum value. So we could actually do, I'm going to get rid of all this. And I'm going to say number equals 99, and I'm going to say print f pick, the number is number colon 10. Come down, and let's take a look. So here's my F string. The number is number colon 10. What is that 10 going to do? Well, let's run it and see. If we were to count all of these spaces down here, that would be 10 characters. So that means it's going to take up at least 10 characters. If you've got 12 characters, that's fine. It'll go ahead and print the 12 characters, no problem. But if I have 10 in there, that says it's going to take up 10. If you don't have 10 in there, I'm going to put spaces in there. And since it's a numeric value, it will align it because it is a number. Another example they have is 1, 2, 3, 4, 5.6789. And down here, I'm going to basically make sure that is a 12 point, let's say, comma, 0.2F. So that says take up 12 spaces, comma separator, round to the 2 decimal places as a floating decimal point. Okay, we run it, and look at that. So we can see the spacing out there. So if I were to count all this, this would take up 12 spaces. And I believe it's 12 spaces up to the decimal point. Because if I were to do this, let's say I've got I don't want to do that. That's too long. Let's see what we get. Yeah, so it does go, it's 12 spaces up to the decimal point. So that's kind of a nice way to align our decimal places. I think they're going to do that on our next example here, which is columns. So let's open up columns. So I got num1, 1 point, yeah, so they're going to do exactly what I did here. So, but notice this. Now this is kind of cool. We've got a printf, we've got our brace num1 10, 10.2f. So it says make sure it's 10 in length, 2 decimal places. And then it's got this next one. So let's put them side by side, and each one's going to take up 10 characters each. So here's what it looks like when it gets done. Notice we've got all kinds of different decimal places there. When it runs, it's like 2 columns. So see how they all line up by the decimal place. So kind of a neat way to do that as well. Another thing we can do is if we look at the top of page 77, we can specify how we want it aligned. Numerics aligned to the right, strings will default to the left, but we can force that however we need to. So if we let's open up a center align. So I've got Gordon, Smith, Washington, Alvarado, Livingston, and Jones. And so each one of those is named 1 through 6. And here I've got F, and it's going to do an asterisk, then the name. And notice I've got this caret symbol. It's an upside down V, and 20. That says each one of those is going to take up 20 characters, and the upside down caret, or the upside down V, or the caret symbol says center align this. So when I run it, notice it's got asterisk, 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 if I were to basically count all of those spaces, it would be 20 characters. Now, if I want it to be left aligned, I'm going to put in a less than symbol. And now watch what happens when I run it. Now everything is left aligned. If I put a greater than symbol in, and run it, everything is right aligned. So some great alignment features we can do there as well. We can also use a concatenation with the F string as well. So we could actually do this. I could have done a concatenate oh, sorry. I need to leave the F in there. Leave the F. Oh. Okay. Adding parentheses. Let's see how that looks. Okay, but notice what it did. It concatenated it all in one line. So that's basically what that does. Okay, the very last thing I want to cover for the chapter, and then we'll talk about Turtle for just a quick second, but it's called name constants. Python, say in other languages, so let's say for Java, I could use the word final, and that says when I set this variable with this value, it can never ever be changed. That's called a constant. For example, pi. I might have pi equals, it's a final pi equals 3.14159. That means throughout that program, I can never change that variable. Python doesn't have that feature built in. So what we do instead is we do this. Is if I create a variable, I'm going to create a variable called pi. So I make it uppercase is equal to float 3.141. Gotta use the right 0.14159. So now I can come down here and say circle equals, is it radius times radius? So we'll say the radius is 34 asterisk 2. Is that times pi? I can't remember. I'm just going to say times. I can't remember by far back. Okay, so here's what we do in Python. Here's what we do in Python. Is we make sure that anything in uppercase we're going to treat as a constant. It can still be changed, but we're going to treat it as one. So that's basically what that means. Okay, I just want to cover this very, very quickly. This is something you can kind of play around with on your own, and I highly suggest that if you want to spend some time doing it, it's kind of a fun little thing to do. But it's called Turtle, and basically Turtle is it says that Turtle Graphics is an interesting and easy way to learn basic programming concepts. The Python Turtle Graphics system simulates a turtle that obeys commands to draw simple graphics. A robotic turtle to reach, basically it doesn't even look like a turtle, but it will basically draw a line and go up. So if we come over here, back here to the classroom, come on, and we click on this editor for Turtle, it won't work in this editor that we've been using. Now in the book, they show something like import turtle and then turtle.show turtle. And so what we have to do instead is we have to say something like this. From turtle import and import turtle as tur. Okay? So what we have to do there is, well, let's just do this. So import turtle, and then t equals turtle. Does that work? And I can say t dot forward $100. Is that going to work? Let's see. Now, hold on. Okay, here's what it is. I do import turtle, and then I want to say t equals turtle dot, and then capital T turtle left and right parentheses. That's basically the method that's part of that turtle. And now the T is actually the turtle. I'm going to say forward 100. And when we click run, now this particular graphic actually has a little picture of a turtle right here, and it moves that forward. So we could actually do this and do T dot, I think it's left 100, and then T forward 100, and we'll do T dot left 100. And let's see what that does. Okay. Let's make it left 90 and left 90, and then T dot forward 100. Let's see what happens. Yeah. We could actually do a 45-degree angle. Let's do 45 and see what happens. Yeah, so there's a 45. So, or I could, now another thing we could do is this. I could actually say what the speed is. So if I do t dot speed, put a number between 1 and 10, 0 being the fastest, or 10 being the fastest, or 0, I guess 0 is the fastest. So I could actually put a 1 in here. And now when we run it, so anyways, you can kind of get the gist of what's going on there. And so this is how the book is going to be different. Again, we have to do t equals turtle dot turtle. So whatever that t is, so you have to create a variable. You could make it tur if you wanted. It doesn't matter. But you're going to have to do at least these two to match the book. And once you have your t, then you can pretty much do everything that they talk about in the book as well. So I'm not going to spend a lot of time on that. So if you want to go ahead and read that chapter. So this is the end of week 1. Again, practice, practice, practice. I would go through some of the different homework assignments, some of the easier ones to kind of get some practice. And we'll go ahead and see you next week.